Hi good people, Titus here for another Unreal Engine tutorial, and in this video I'll show you how to create a simple grid system using hexagons. We'll be demonstrating the flat top orientation in this example, but let's not waste any time and just jump right into it. Alright, we're actually going to hop into Blender starting off because we need to make a hexagon because I don't have one. So I got the default scene, so I'll press X, hit delete, then Shift A, add a static mesh. We're going to choose cylinder. We'll expand out the cylinder properties. We'll set the vertices count to be 6. And then the depth I'm going to lower to be 0.25. And I think that looks pretty good. If you're doing pointy top, you'll want to rotate the Z-axis along 90 degrees. In this example, I'm going to be doing flat top, so I'm going to set that to 0. Hit tab, I'm going to go into face mode, select the top face, press I to inset, click to confirm that, and then press Alt S to push this up just a bit. That way it gives a little bit of contrast and light catching to have that little edge there. And then I'm going to go File, Export, do FBX, go into Pick a Location. I'm going to limit it to the selected objects. You can see I have the cylinder selected. And then for the transform, I'm going to set the forward to be the X positive and the up to be the Z positive, which is specific to Unreal Engine. Your game engine may use a different transform, so just make sure you know what that is. Then we'll give it a name. I'll call it Hex Flat Top, and then I'll just hit Export. And then we're good with Blender. We can go back to Unreal. I'm going to go File, create a new level. We'll choose a basic level, hit create, then I'm going to select the floor and delete it, just so we have a good starting point here. Then I need to import the static mesh we just made, so I have it right here. I can just drag it into Unreal, leave the defaults alone and just hit import all, and then we're good. I'm going to right click, create a new blueprint class, choose type actor, and we'll call this BP underscore hex. And I'm doing the flat top orientation, so I'll choose flat top. We can double click and dock that into our main scene here. To make this work, we're going to need to add a singular component. To demonstrate it, I'm going to use a instanced static mesh. And then I'll leave the name as the default. We're going to be creating 4 functions. The first function we will call calculate sizes. That'll give us our diameters and our radii, which there's 2 of each. Our second function we'll call vertical space, which will calculate the vertical spacing. Third function is the horizontal space. Fourth and final function is our offset hexagons. This will calculate the offset for every other row or every other column, depending on how you layer or do your orientation. We're going to need a bunch of variables, so we can hit the plus sign here to add a variable. First one will be radius small. The data type is going to be a float. Then we'll hit the plus sign, and this one's going to be radius large. And then we also need a diameter small. And then we need a diameter large. Then we also need a offset, which will be a public variable. So we're going to hit the little eyeball right here to expand that. This will be editable in the inspector or in the level editor. So you can maybe add some spacing between your hexagons if you're looking for that sort of aesthetic. The next variable we'll add is going to be a scale. This will also be editable on the fly, so I want it to be public, so we'll hit the eyeball there. And then the final float value we need is a row offset. That is going to be private though. And then we need some integers. You can call these columns rows. I'm going to go with height and width. Just make sure you set the data type to be an integer. These are also going to be public. This is basically going to be how you size out your grid system in your level. And then we will add width, and that will be public. And then the final variable I need is a tile mesh. If you expand out the data types and search static mesh, there's a static mesh section, just choose the object reference. And then you can make that public if you want. I will leave that, actually I'll leave it public, that's fine. Either or is fine. We'll want some default values here. The tile mesh, we can set to be our hex flat top that we made in Blender. The height and width I'm going to set to be 10, so we have a starting grid when we drag it into the scene. The scale we need to set to 1, because if you leave it at 0, you're never going to see your grid, because everything's scaled to 0. And that's actually the last thing you need to set, so you're good on your variables. So we can compile and save, and we can begin writing our construction script. So we'll go to construction script here. We will drag into a set static mesh. Make sure it references the instance static mesh that you created in the component tree there. And then for the new mesh, we can just use the tile mesh variable we just created. We can then pull into our first function called calculate sizes. This will give us our 2 radii and our 2 diameters. From there, we can pull into our first for loop. The first for loop should start at 0, and then it should go to the end of height. Basically, the last integer value in your height values there. In the loop body, we will pull into the horizontal space function we set up. Then that will go into a second and final for loop. We'll start at 0, but this time we're going to be checking the width on this one. And we will orient these like so. In the loop body of this one, we will pull into the vertical space function we created. And then after the vertical space function, we are going to add the instance of our static mesh. Make sure you choose the singular version, not the plural. So add instance. It's a good idea to split the transform and then split the location. We're only going to be working in the X and the Y. For the scale, we can drag in our variable scale. It'll automatically make the conversion for us. Like so. And that completes the skeleton of our construction script. We can go ahead and start defining the functions. Let's go to the calculate sizes function, and we need to hold control, drag out our tile mesh, pull off that into a get bounding box, and then we want to split or right click split the return pin, and then you can right click and split the max value. We won't be working with min because they're negative values and they won't help us in any way that I can think of, so we don't need them. We can pull off the max X value into a multiply node, and we can press Ctrl D and duplicate that multiply node and hook up the max Y into this one here. We can then take our scale and we can multiply each of these values against our scale value here. And this is how we're going to set our radius small, so we can hold Alt, drag that in here. The radius small is going to, if you need to tell if it's between the X and the Y, you can simply double click your static mesh. Let's go to the top view. And we can show bounds. If you look in the bottom left corner, we have our X and Y. So this is our X and this is our Y. So the hexagon has 2 radii. It has a small radii, which is, you can see from center to the flat portion here, and then it has a larger radii, which is from the center to the pointy tip. Now, if you notice, the shorter one is on the X-axis. the larger one is on the y-axis. So the max x value is going to be our small radius, and then the max y value is going to be our large radius. Hopefully that made sense. Depends on your static mesh and how you have it oriented is basically what I'm saying. Off the small radius, we can pull into a multiply node. Simply double it, and then that'll be our small diameter. So hold Alt, drag that in here. And then off the large radius, we can multiply that against 2. And then we can hold Alt and drag in our large diameter and plug that in here. And that is how we get our small radius, small diameter, and large radius and large diameter. So we're pretty much good on that function. Let's move on to the, we'll do the vertical space function next. So on a flat top orientation, the vertical spacing is calculated by the square root of 3 times the large radius. So we can right click and reference square root. We'll pop in the value 3, pull off that into a multiply node. I'm going to hold Control, drag into here, and I'm actually going to move this up here. And then I'm going to add a pin, and we need our large radius. So drag that over here. Now we're also giving us the ability to add an offset to our grid, so we can add that into this function as well. What you'll need to do is pull in our offset variable, hold Control, drag it, pull into a multiply, and then I'm going to hold Control, drag that in over here. And then what we need to multiply these against is the hexagon number that we're instantiating. So from an, like if you think of like we're doing a hex grid, you're going to have probably like a grid of 10. So from 1, 2, 3, 4, 5, 6, 7. You want to scale that out because the way this is doing it is it's doing it from a center point, and the rest of the hexagons are going to basically scale out from that edge corner. So you need like a scalar against it. So the hexagon number will be perfect to make that work. But what we need to do is we need to select the purple node here, and we need to add an input. The input we can call whatever. I'm just going to use hex number, and this data type needs to be an integer. So now I can basically plug that in here, and then I can also plug that in down here, and I can double click and make this look fancy. We then basically pull into an addition node, and we add these two values together. And now we need a return value. So under the output nodes here, we can hit the plus sign, and we can just call it return value or whatever you want, doesn't matter. The important part is that it's a float. So we'll switch integer to float. And I just pop this in here, compile and save, and that's good. So the next function is the horizontal. We're going to do the same thing. We'll add an input. This one's going to be our hex number. This was an integer. And the horizontal spacing on a flat top orientation is calculated by taking 3/4 times the diameter. In this case, the large diameter, since it's going to be on the pointy sides basically. So what we can do is take our large diameter, hold Control, pull into a multiply node, hold Control, drag this down here. I'm going to add a pin. 3/4 can be expressed as a decimal 0.75. And then we need a scalar, so we'll multiply that against the hex number being instantiated. Now we need to add in our offset for this as well, so hold Control, and this is going to be just like we did before. Pull into a multiply node, pull this down here, move this up like so, move this back, and make it look fancy. And then we'll pull into an add node. And another way you can add an output pin is you can actually just simply take the return value and drag it into the purple node. It'll automatically add your return type there, if that is easier for you. Okay, so that completes our horizontal spacing. So now, last but not least, is our offset calculation, which is pretty simple. We simply will take our small radius and multiply that against -1. And then we will set that to be our row offset by holding Alt, dragging that in. So it gets a setter, and then we plug this in here. We don't need any input or return types. This is basically just gravy. The reason we need to calculate an offset is because we're still using a square grid-based, we're using a square grid system of hexagons, and they slot together with an offset. So they're basically either shifted up a little bit or they're shifted left or right a little bit. And that way they kind of like hook together kind of perfectly. So every other row or every other column, depending on your orientation, you'll need to shift slightly over. But now we need to actually use all these functions. So let's go back to our construction script. And this video is already getting a little bit long, but I'll try to make this quick. You'll notice on our for loops, we have an index on how many times we're looping through our height and width values. We can take that index and now plug it into our input pin on the horizontal and the vertical functions. And then on the functions, we also have an output pin now. If you look at our add instance, the horizontal spacing is actually going to go in the Y value for this orientation. So I will drag this into Y, and I'll give us some space over like so. Now the vertical spacing is going to go into the X, but we need to add our row offset because and because this is the flat top orientation, it's going on the vertical side. So we will pull this into a add operator, and then we can just add our row offset in here, and then this will go into the X. But how do we actually get our offset calculated? Well, after we do one iteration, so after we instantiate one hexagon, basically when that's completed, so off the second for loop, we can pull off the completed into a flip-flop. And then under the A channel, we can call the offset hexagon function. Otherwise, off the B channel, we can just set the row offset to 0. So we'll hold Alt, drag this over here. And I'm gonna actually drag this up maybe a little bit. I think this one's the problem. There we go. So basically flip-flop will basically execute 1, then the next time it loops through, it'll execute B, and the next time it loops through, it goes through A. Kind of basically flips and flops and goes through. If for some reason you're working in a game engine that doesn't have a flip-flop, another way you can do it is just simply do it on the even number ones. Whether it's the even rows or the even columns, however you want to do it there. You should know the number because you're controlling that, but if for some reason you're writing the code in such a way where you don't know the instance that you're on is either even or odd, a way you can check is using the remainder property or modulo, however you pronounce it. Basically take the number and then divide it by 2 and then check that against the modulo. If the remainder is 0, then that was an even number, and then you can use that. Otherwise, it's an odd number. But if you're working in Unreal Engine, simple flip-flop will actually get you where you need to be. But okay, so if we did all this right, we can come back to our viewport here, and we can hit compile, and you see we have this lovely grid. And if we save and go back to our map, drag this in, reset the position to be 0, 0, 0, And then if we play, I can drag and kind of move around, and I have a nice little grid system here. Pretty basic. If we see the controls in the inspector, you'll notice we have our offset. So it looks like that works pretty good. So you can basically offset if that's your thing. You can scale, make it bigger or smaller, or you can just simply expand out your height and your width of your grid. And remember, this is a flat top orientation, so it's one particular way to set this up, but you have options. Now, one notable call out is this is not a very good scalable solution because it's expensive, and that's mainly because we're using a instance mesh and using that mesh we created in Blender. So you'll notice if I bump the numbers or something crazy like 100 by 100 and try to play, I was getting 120 frames. Looks like I'm still doing okay there. Let me flip it to maybe 300 by 300. Oh, there you go. You can see it's kind of lagging. And I'm dropping 86 frames. And now if I try to play this, I'm probably not going to get as good. Well, I'm still getting 120, maybe because it's on the construction script, but it's going to be a little bit laggy and it's going to take a while to actually load up. So just be aware of that. It's good for small grids, but not for super large grids. If you need a large grid system, I did a tutorial on a square grid system that used a procedural mesh instead of the instant mesh. It's a more complicated setup though, because you have to define the vertices and their orientations to get the normals right. But if you do that, you can easily get like 1,000 by 1,000, and you won't have any trouble because it's extremely performant with that particular one. All right, good people, we'll cut it here. I hope you found some informative value that you can take into your own projects, but as always, thanks for watching, consider subscribing, and see you on the next one.